Ever wondered about the origins of everything we see in the night sky? Let's take a step back, way back, around 13.8 billion years back to be precise, to an event known as the Big Bang. The Big Bang wasn't an explosion in the traditional sense, but rather a moment when the universe, which was once compacted into a single point of infinite density, began to expand. Picture a balloon inflating, but on an unimaginably colossal scale. This expansion happened at an astonishing speed, making the universe larger and cooler. As the universe cooled down, the elementary particles, protons, neutrons, and electrons started to come together. They formed atoms, primarily of hydrogen and helium. These atoms were like tiny seeds, the building blocks that would eventually grow into galaxies, stars, and everything else we see around us today. But how did these atoms turn into stars and galaxies? The answer lies in gravity. This fundamental force pulled these atoms together, creating dense pockets of matter. These pockets became so dense and hot that they ignited, giving birth to the very first stars. These stars didn't live long, but their death was not in vain. In their fiery demise, they produced heavier elements like carbon and oxygen, which are essential for life as we know it. These first stars clustered together, forming the earliest galaxies. Just imagine, these galaxies were forming when the universe was still a toddler, barely a few 100 million years old. These galaxies then continued to evolve, collide, and grow, leading to the diverse cosmic landscape we observe today. From that single point of infinite density, our universe expanded and evolved, setting the stage for the creation of everything we know today. It's a mind-boggling journey, isn't it? But hold on to your hats, folks, because this is just the beginning. The real excitement lies in what happened next, in the cosmic dust of these early stars and galaxies. But that's a story for another scene. But how did all that cosmic dust and gas turn into our solar system? Well, the story begins with a giant molecular cloud, a celestial nursery if you will, where stars are born. These clouds are vast, spanning light years across, and they're filled with a mix of gas and dust, but they're not static. In fact, they're incredibly dynamic. When a part of this cloud gets a nudge, perhaps from a supernova explosion, or the tidal forces of a nearby galaxy, it starts to collapse under its own gravity. As the cloud collapses, it fragments into smaller and smaller clumps. Each clump continues to collapse, spinning and heating up as it condenses. At the heart of each clump, a protostar starts to form. This is the embryonic stage of a star, a hot, dense core of matter that will eventually ignite to become a fully fledged star. For our solar system, one of these protostars was the sun. But what about the rest of the material in the cloud? As the protostar that would become our sun continued to form, the remaining gas and dust began to orbit around it, forming a flat, spinning disk. This is known as a protoplanetary disk. Now within this disk, particles started to stick together, clumping into larger and larger bodies. Over thousands of years, these clumps grew into planetesimals, the building blocks of planets, and over millions of years, the planetesimals collided and merged to form protoplanets. Finally, after a few more rounds of collision and merger, the protoplanets became the planets we know today. But it wasn't just planets that formed. The same process also created moons, asteroids, and comets. So you see, our solar system is the result of a complex dance of gravity, matter, and time. A process that took billions of years and involved countless particles of dust and gas. A process that transformed a giant molecular cloud into a bustling neighborhood of planets, moons, and asteroids. And so, from the ashes of dead stars, our solar system was born. So we have a star and a cloud of dust and gas. But how does that become a planet? Well, let's dive into the fascinating process of planetary formation. Picture this: a sea of dust and gas swirling around a young star, our sun. Within this cosmic soup, tiny dust grains begin a dance of destiny. They collide and stick together, gradually forming larger and larger clumps. This process is known as accretion. These clumps, now the size of small asteroids, are called planetesimals. They continue to grow, attracting more dust and gas through their increased gravitational pull. As these planetesimals collide and merge, they form larger bodies called protoplanets. Now, these aren't quite the planets we're familiar with yet. They're more like planetary embryos, still growing and evolving. As they continue to collide and merge, they accumulate more mass, and their gravitational pull becomes even stronger. This process is a bit like a cosmic demolition derby, with protoplanets smashing into each other until only a few winners remain. Then comes a process called differentiation. As these protoplanets grow, their interiors heat up. This heat, combined with the force of gravity, causes the heavier elements to sink to the center, while the lighter elements rise to the surface. This process results in a layered structure with a dense core and a lighter crust, much like the structure of Earth today. Finally, these protoplanets start to cool down. As they do, their outer layers solidify, forming a solid surface. This is the final step in the formation of a solid planet. But even after a planet has formed, it can continue to evolve and change over time, thanks to processes like volcanic activity, weathering, and the impacts of asteroids and comets. Through a process taking millions of years, the dust and rocks swirling around our young sun gradually formed the planets we know today. So the next time you look up at the night sky, remember, each star you see could be the center of its own cosmic demolition derby, with planets in the making. But what about our home, Earth, and its faithful companion, the Moon? Let's take a trip back in time about 4.5 billion years ago, when the Earth was nothing more than a hot, molten mass. This was a chaotic time in our solar system, known as the era of late heavy bombardment. Comets and asteroids were careening around the solar system, smashing into planets and leaving their indelible marks. Our Earth was not immune to this celestial bombardment. In fact, one collision in particular stands out from all the rest. A Mars-sized body, which we'll call Theia, collided with the young Earth in a glancing blow. The impact was so immense that a large chunk of the Earth was dislodged, catapulted into space, and began to orbit our planet. This debris over time coalesced and formed what we now know as the Moon. Following this dramatic event, the Earth began to cool down. The molten surface started to solidify, forming the first crust of our planet. As the Earth continued to cool, water vapor began to condense, forming clouds, and eventually, it began to rain. This rain filled up the depressions on the Earth's surface, forming the first oceans. But what about the atmosphere? The first atmosphere was likely composed of gases like methane, ammonia, and water vapor. However, with the emergence of life, particularly photosynthesizing bacteria, oxygen began to accumulate, leading to the formation of the oxygen-rich atmosphere we breathe today. These events, the late heavy bombardment, the impact that created the Moon, the cooling and solidification of the Earth's crust, the formation of the oceans and the atmosphere, all played a crucial role in shaping the Earth as we know it. So next time you look up at the Moon, remember that it's a piece of our own planet, blasted into space billions of years ago. So what's the story of our solar system in a nutshell? Let's take a quick trip back in time, shall we? We began our cosmic journey with a bang, the Big Bang to be precise. This monumental event marked the beginning of everything: time, space, matter, energy, you name it. From a singular, infinitely dense point, the universe exploded into being, expanding at an astonishing rate. As the universe cooled and expanded, matter began to coalesce into the first atoms, primarily hydrogen and helium. These atoms then clustered together under the force of gravity to form the first stars and galaxies. These celestial bodies, glowing hot and bright, were the building blocks of our universe, the forerunners to everything we see around us today. But how did our solar system fit into this cosmic tapestry? Well, that's where the story gets even more fascinating. Our sun and its orbiting bodies, including our very own Earth, were born from the remnants of older dying stars. These stellar nurseries, rich in elements heavier than helium, collapsed under gravity, sparking the formation of a new star, our sun, and its surrounding planets. Our Earth, the place we call home, was a fiery, molten mass in its early days. Over billions of years it cooled and solidified, with water vapor condensing to form our oceans. A chance collision with a Mars-sized body led to the creation of our Moon, forever tying our fates together in a celestial dance. This grand cosmic saga unfolds over an almost incomprehensible timescale, stretching back around 13.8 billion years. And it's not over yet. The universe is still expanding, still evolving, and who knows what new wonders await us in the depths of the cosmos. So there you have it, a journey from the Big Bang to the world beneath our feet, all in the space of around 13.8 billion years. Who knows what the next chapter in this cosmic story will be?